Hi friends, so we are in our fourth week, that is on risk conscious culture as part of risk conscious operation management for complex engineering system, the course, and then as part of RCC, that is risk conscious culture, we will be discussing in this lecture human and organizational factor, the core of the culture. Okay. So let us start. Historically, any accidents would happen, and then human factor will be blamed, whether it is aviation, whether it is in industrial system and all that. But then there was a realization that humans are interacting, they are part of man-machine interface. But then sometimes there could be procedural error, there could be design issues, there could be assumptions that were made that within this much time the operator will respond, which was too constrained in time domain, and there are movies have been made on this, that whatever we design, whatever we perceive, the scenario in real time is different. Okay. Maybe one or two movies have been made on in aviation accidents, on Hudson River. You can see that thing. Organizational factor comes into the picture, and then a very recent accident realization has been that the culture also is part of the or can be attributed to the accident. So slowly things are unfolding in respect of accidents. Now this realization which is there, then the issues that were found out was safety analysis, as I mentioned, procedural issue, capability of or quality of the training also, in training as well as in qualification. And the current approach, this laid out the foundation for organizational and human factor analysis. So that's our topic today. Analysis of accident. In many accidents, last 4 decades, organizational culture has been held responsible, as I mentioned. And now with this introduction, let us come to our topic. In RCC, what are the risk conscious in respect of human and organizational factor? What should be the desirable attribute? If I make a risk conscious culture policy, then what are the desirable attributes? Okay. So one is that of course the policy should be very crisp, clear and brief. It is communicating the role of organization and role of individual to meet the highest level of standards of safety. Okay. Now often when the policy is drafted, it is seen in the context of government rules and regulation, ethics, all those criteria are examined, and then only the policies, and in fact policy is a approved element, whether at regulatory level, at the national level or national level. So it should be approved, and then once the policy is declared, everyone has to follow it. Simple. If everyone has to wear helmet when we enter the working area or field, then it's a policy decision. Everyone has to abide by that. If we don't wear the helmet, then there could be some not penalties, but training, retraining, and it is human that we are dealing in. So the best practices, I cannot tell 1, 2, 3, 4 and all. But then wearing helmet is industrial safety. But when we go to the complex engineering systems, every bit of human behavior affects the plant, and sometimes it might go unnoticed, but sometimes it might manifest as in terms of deviation, plant reliability, availability and all that. Then major element of policy include regulatory compliance. Regulatory compliance is one of the area where due importance is given as part of the risk conscious highest standard of safety, availability of integrated risk assessment and management framework. This framework might include the software, simple like software where risk assessment can be formed, a policy decision in terms of data collection, data analysis, data management, data updating, because unless until we have a good data, we cannot have a good model. Okay, and then I have given this symbolic thing. If my plant knows that what is the risk level, like a meter, how I know the speed, and whether I am not into this prohibitive zone, red zone, I am here only in this zone. So okay, we like there should be something available at the visualization level in a simplistic way. So this is what, so it can be called as matrix, policy matrix and all that, where we can see the risk or safety very clearly, and we can see what has gone wrong down the line, a deductive approach to understand that, but that is an analytical thing. This particular illustration, anybody in the plant, right from grassroots level to a management level person will understand. So these are the desirable attitude. Now you see, plant is not something that it operates only in one state. The plant has got a range of states, and for each state the rules they might change. Like for example, there is a high hazard in certain area when the plant is operating, but when plant shut down, the radiation levels have gone down and one can work freely after a stipulated time. So you can see the same plant from its state of operation, or for accident condition, certain areas will become prohibitive, certain areas will remain open for work and all. So, when we draft a policy, one should know that it is consistent with the different state of the plant, and there is no confusion in respect of. So, typically we can see there are two major categories. Plant is either operating smoothly, okay, and our plant is in accident condition. If we go down, we have two states here: normal operation, that is plant is operating. Even plant shutdown is also considered as part of normal operation. And then anticipated transient. What is anticipated? The accident which we were expecting during the life of the plant. The frequency could be from 1 per year to it could be 0.001 per year. So that is the, so we know that this like power failure. Power failure means electrical power disruption. It will plant will encounter that condition, and that is given the name loop, loss of offsite power failure. So this will happen in the plant, and plant should have a provision. So these are called normal operation states, and here it has gone into this, it is called transient. So this also is named as transient. And in plant there are provisions to handle this kind of thing. Okay, and then if we are not able to control the transient and bring the plant to safe state, then it will enter into the design extension condition. That means now there are some provision, this is a gap area. It will not enter into the design basis accident directly, because there is a possibility of recovery to come back to this state by certain action, by safety action and all that. But if it is not controlled, then it will go to the design basis accident. Design basis accident means an accident which has happened for which the provision existed in the design, provisions existed in the plant, and by which the plant can be brought back to this state. But if this situation goes out of control or beyond this, then it will again come into design extension condition. Here there are some recovery possible, we will come back here, otherwise we go to beyond design accident, and this is the most undesirable situation for any plant, highly undesirable, because after that the hazard might reach in public domain, okay, and it can have its own consequences. So this is what the plant state and how we should take coverage into the RCC. Okay, this is a very, very pragmatic view we can have for implementing the risk conscious culture, and which is where the human and organizational factors are at the core. Now, as I showed you one diagram, there is a meter and you know the risk level and all that. Risk conscious culture, the major elements are, first thing, design safety, deterministic safety analysis, good. But then for all action or for application point of view, we are using probabilistic risk assessment, okay, along with the deterministic, of course. Here we should have a probabilistic risk assessment model of the plant. Now we will discuss what should be the maturity. So this model PRA, we call PRA, we have been using this. This model should be available and this should be updated model as part of a good culture. You know, the plant as built, as operated situation should be reflected in the PRA model of the plant. Then identification of, since we are talking about the culture, we have to identify the human elements. Which are the human elements which are contributing to the accident sequences, and those accident sequences in turn are leading to the plant damage states. It could be any plant, process plant, any type of, or it could be one societal system also. So where we are entering into the accident situation. Now these actions can be identified by looking at the, I think we discussed this cut set list, where all the components have been listed based highest to lowest. Okay, and then if it is a human element here, these two becomes important for us. And human element with common cause failure, we have discussed common cause failure also. Common cause failure means one failure or one event leading to multiple failure of redundant system. That means normally in redundant system there is one operating, there is a second, third, it depends on the level of all the system, all the redundancy is knocked off. So that is called common cause failure. But suppose if for this knocking off, if human element was responsible, then it becomes a serious issue. You know, because human action should not lead to common cause failure to the extent possible, or it should be unlikely. And that is why the training, qualification, these courses are given. Okay, this is one thing. And then, as I mentioned, availability of monitoring system, risk monitoring system. We monitor pressure, temperature, flow, so many nuclear parameter, various gases flow and all. We do monitor those things. But monitoring risk. So here we are showing one matrix here where risk is shown here, and this is the threshold value. One bar is showing the threshold value for the risk. It should not go to this limit. At the same time, if I have taken some action, the risk has increased, but because I took one component out for service with due approval and all, but for that duration the risk has increased, but I had made redundant provision. It could be monitoring, it could be extra standby pump, whatever, or so I made that provision, but plant risk has increased and it came back to the normal value again, and that's how. But all these things plant alone cannot do. It has to go by one document called technical specification or safety technical specification. If it doesn't permit, you cannot do it. If you want to do it, then regulatory approval is required. Okay, so safety is a very complex subject, and then so what is happening is, if I do something, if I feel there will not be any risk component, but my technical specification doesn't permit, which is in the boundary of operations only. So I can do that. Like suppose I made one change and risk has increased, so decreased. So here I can do that change. That means I wanted to do one maintenance on a blower, which I felt whether risk will increase or not increase, but it was found out the risk remain either unchanged risk remain either unchanged like here, or it reduces slightly, or it doesn't increase actually. For our concern is, and even if it increases, our regulatory document or our international standard, they will say it should not be more than 1%. It should not be. So that is also acceptable. What we are talking about is, as part of risk conscious culture, we are having flexibility, and our same safety technical document which was operating with stipulations. Okay. Now we can see some flexibility. Maybe sometimes might to go to regulator, or you might do on your own, or plant itself can take a condition. Okay. So risk monitor is one important tool in the plant. Many of nuclear power plants have risk monitor. They are at the back of the control room where assessments are done. What maintenance action can have its manifestation in terms of increasing, decreasing, or remaining same level of risk and all. So this is the now. Human reliability is a separate chapter or separate lecture on this. So here I am just in short, I am covering the central idea of CQB, that consciousness, cognition and conscience is our human model, and their main machine interface and organizational factor both are covered, and which are the critical sense bases or sense bases alone. Human basis, that is the brain which is processing the information. Okay. We have brain, we have eye for visualizing the thing, ear for conscious hearing, nostril for conscious smelling, skin for conscious touch, and mouth for taste. Of course, this we may not use, but skin, smelling, if there is a burning sensation somewhere, you go to any plant area and you see, so some electrical, this is a signal of some electrical failure, short circuit or something. So all this thing, sense basis should be perfect. Missing on them might miss the plant symptoms or signals. Okay. Same way, you will be observing the noise. So that will happen from the ear, that conscious hearing, and if you miss that, accident. And other action elements are brain nervous system. That means from brain the signal goes to hand and legs, and mostly these two, and the actions are completed. So, but the details will be discussed in the human reliability, in human factor in operation. There is a separate module as part of risk conscious operation management for complex engineering system. So overview is, we have seen enhanced framework for risk based framework for conscious role of PRA we have discussed. In fact, PRA only forms input for developing a risk monitor. Okay. So, and PRA should, as the PRA is updated, the risk monitor also should be updated, because we want the risk monitor should reflect as built, as operated state of the plant. And human organizational factor, in short, we have touched upon, and then technical element we will be discussing in the next lecture, and conclusion and remark, that will be part of the next lecture.